Dr. Halizah Basiron. So we start now.
Hi, Assalamualaikum. Can you hear me?
Yes, Dr. Halizah, we can hear you clearly.
Sure, thank you. Okay, shall we start or what?
Assalamualaikum warahmatullahi wabarakatuh. Good morning. Before we proceed with the program, I would like to take a moment to extend my heartfelt gratitude to our esteemed speaker, the Honorable Halizah binti Basiron PhD, MSc, PhD from Teknikal Malaysia, Melaka University. The Honorable Dr. Aris Puji Widodo, SSc, MT, as Head of Informatika Department, Fakulty of Sains and Matematika Diponegoro University, and the audience who have agreed to attend this morning's event. Your presence and attention are greatly appreciated, and we are honored to have you here with us today. First of all, let us pray and praise to Allah Subhanahu wa Ta'ala, because His blessed and mercy, we can come together without any obstacle here with healthy condition in the visiting lecture with the theme Natural Language Processing, Development, and Application. Here, and Sylvira Nabila Anggita Gradi, the Master of Ceremony, will quit this visiting lecture. But before starting our agenda, let me explain the agenda schedule of the visiting lecture. 1. Opening. 2. Opening speech from the Head of Informatika Department, Faculty of Science and Mathematics, Diponegoro University, Dr. Aris Puji Widodo, SSc, MT. 3. Virtual photo session. 4. Visiting lecture session, Natural Language Processing, Development, and Application. 5. The question and answer session. 6. Closing. To commence this event, let us recite the basmalah together. Bismillahirrahmanirrahim. Next, for every participant, don't forget to fill in your presence on the link that has been sent in the chat. Turn on the camera during the event, and use the virtual background that has been provided. Moving forward, it is an honor to invite Dr. Aris Puji Widodo, SSc, MT, to deliver that opening remarks. For Dr. Aris Puji Widodo, SSc, MT, time and
Bismillahirrahmanirrahim. Test. My son here?
Yes, Dr. Aris, we can hear you clearly.
Yeah. Okay. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Honorable speaker for today, Ms. Halizah Basiron PhD from University Malaysia, Melaka. My beloved lecturer and student of the Informatika Departemen University itu kan. First of all, let us express our gratitude to Allah that might be because for His blessing we are still given for the opportunity to able to get in today. Public lecture is application itu kan. As we know, P is a subfield of artificial intelligence that focus on the interaction between computer and human language. NLP development involves creating algorithm model into understand, interpret, and generate human language. NLP has application most far as industry and domain. He some key aspect NLP development and its application is text classification, name entity recognition gitu kan, mesin translation, chatbot and virtual assistant, sentiment analysis, speed recognition and document analysis gitu kan. Last but not least, I would like to thank that all committee and all those who have helped organize this event. I hope that with this event we can continue collaboration on research, learning, student acting, and other. We hope that today public lecture will be able to provide an insight and update on the application of recent technology. Please enjoy today public lecture. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Thank you, Dr. Aris Puji Widodo, SSEMT, for your opening remarks. Then we entered the photo session together. I kindly request everyone to turn on your cameras and smile for the screen and use the virtual background that has been provided. Okay, to everyone, please turn on your camera and we start to take photo.
Okay, so we're gonna begin to take a photo. So there is 5 slides around the Zoom, so we're gonna take it 5 times. I kindly reminder to open your camera once again. Okay, at 9:18, we're gonna take the first photo. Okay, we're gonna start to taking your photo. Hold your smile. 3, 2, 1. Okay, this is our first slide. Great. Okay, for the second slide, hold your smile. 3, 2, 1. Thank you. For the third slide, hold your smile. 3, 2, 1. For the fourth slide, hold your smile. 3, 2, 1. And for the last slide, hold your smile. 3, 2, 1. Okay, clear. Back to the MC. Thank you.
Okay, thank you, Axel. Moving on, we come to the main session, that is visiting lecture with the theme Natural Language Processing Development and Application by Halizah Basiron, BSc, MSc, PhD. The main session will be guided by Ms. Yunila Dwi Putri Arianti. Ms. Yunila, the time is yours.
Okay, thank you very much, Ms. Safira. Is my voice heard?
Yes, voice heard clearly.
Okay, thank you. It is my pleasure to be the moderator of this session. The Honorable, the Head Department of Informatika, Faculty of Sains and Matematika, Universitas Diponegoro, Dr. Halizah Basiron, SSI MT. The Honorable, our visiting lecturer, Mrs. Halizah Basiron, PhD from Faculty of Information and Communication Technology, Universiti Teknikal Malaysia, Melaka, Malaysia. The Honorable Lecturer and Staff of Departemen Informatika, Universitas Diponegoro. The Honorable all participants, students of Departemen Informatika, Universitas Diponegoro. Good morning. Assalamualaikum warahmatullahi wabarakatuh. First of all, let us thank to the Almighty Allah Subhanahu wa Ta'ala, because His blessing we are able to join this event. Visiting lecture held by Department of Informatika, Faculty of Science and Mathematics, Universitas Diponegoro, with the topic Natural Language Processing, Development and Application. Ladies and gentlemen, now we are come to the main session of the visiting lecture. In this special occasion, we have our special guest lecturer today, Mrs. Halizah, Dr. Halizah Basiron from Universiti Teknikal Malaysia, Melaka, Malaysia. So we would like to give our special thanks to Dr. Halizah for joining this event. All right, ladies and gentlemen, before we start this session, it is my great pleasure to introduce the profile of Dr. Halizah Basiron. Dr. Halizah Basiron achieved a Diploma Computer Science from University Technology Malaysia in 1991, and then Bachelor of Computer Science with Honors from University Technology Malaysia in 1993, and Master in Interactive Computing System Design from University of Loughborough, UK in 1997, PhD in Computer Science from University of Otago, New Zealand in 2012. Dr. Halizah Basiron is currently as a senior lecturer at Department of Intelligent Computing and Analytic Faculty of Information and Communication Technology, Universiti Teknikal Malaysia, Melaka, Malaysia. As a researcher, Dr. Halizah Basiron has published high-quality research related to her research interests, and her field of specialization are natural language processing, sentiment analysis, and machine learning. Dr. Halizah Basiron has also achieved prestigious rewards. Some of these latest rewards are Outstanding Service Award in 2013 and Outstanding Service Award in 2019. Dr. Halizah Basiron has 7 recognition with the product names MUET Corpus and MUET Lex. From the product, she got 4 gold medals and 3 silver medals. And so our participant today, Dr. Halizah Basiron, is going to talk about one of the current interesting topic, natural language processing development and application, which is in line to the Dr. Halizah research interest and experience. Therefore, there must be a lot of valuable information we can benefit from Dr. Halizah lecture today. Before we start the session, let me read the agenda today. In the session, we have 2 agenda. The first agenda is the main lecture from Dr. Halizah. It's about 60 minutes. And then the second agenda is question and answer for about 30 minutes. And we expect all participants to be actively participate in the Q&A session. During the session, you may type your question in the chat panel, or you may also deliver your question directly to Dr. Halizah in the Q&A session. Okay, well, ladies and gentlemen, let's start the first agenda in the session, the main lecture presented by Dr. Halizah Basiron, with the topic of the lecture is Natural Language Processing Development and Application. Moving along to our session, please welcome Dr. Halizah Basiron. The time is yours.
Okay, thank you very much. Assalamualaikum and very good morning to all of you. Your Honorable, the head of Informatics Department, Faculty of Science and Mathematics, Universitas Diponegoro, Dr. Aris Puji Widodo, the honorable staff, the lecturers, and also the students who are joining this event. Thank you very much, for inviting me for this public lecture on natural language processing. I am actually honored or grateful that being invited to this event. Okay, let's start without further ado. I hope that you all now happy, in a good mood. Okay, I don't want to be like very formal basically, because normally my class is not so formal. It's make me nervous basically, even though we are online, right? So make it quite slightly informal and so on. Okay, okay, let's start. Let me share my screen. Okay, during my lecture, participant can actually interject me, just give me a question, okay, throughout my lecture. I think I cannot see the chat box. Maybe the moderator, okay, Miss Yudila Dewi may stop me if there are a question from the chat box, or the participant can just unmute your mic and just say the question. Okay, so basically the person who actually emailed me is Dr. Sandi Kurniawan. Okay, first time email me asking me to give this topic. I'm actually quite surprised, but yeah, it's good because I would like to share some knowledge that I have. Okay, some experience about this NLP, and why not? We all share and benefits from this area. Okay, let's go. Let's move on. Okay, this is my university. We are located in Melaka. Melaka actually is known as a historical city of Melaka. Okay, so we are if you can see here, Melaka is just about 130 kilometers from Kuala Lumpur. Okay, and this is my faculty of Information and Communication Technology. We have about 5 degrees, okay, undergrads that we offer, 1 diploma, and also we have masters and postgraduate studies. Okay, so this is my topic that I would like to share. Okay, I hope that all of us will get or benefit from this topic. About me, I think Miss Yunila has actually explained about me. So okay, so I just skip this one. Okay, so this one is my academic background. Okay, this is my student. Okay, I just take the photo last Tuesday, my class. Currently, I teach artificial intelligence, okay, for my class. So these are my students. It's around about 80 students. Okay, so as mentioned by Dr. Miss Yunila, my academic background, yeah, I starting from 1991, my diploma in computer science and my bachelor degree also computer science, and then in master I did it in University of Loughborough in UK. I did about interactive computing system design, something about the human something about designing interface. So starting from that, basically I like the topic of natural language processing, because starting with my dissertation, I did a project on a component of natural language generation. So basically that one, I built a small system on question and answer, whereby the system will accept a question in natural languages, and the system will provide the answer in natural languages. Okay. Then coming to PhD, okay, I also continue the area. So this part is more on the error correction, especially on learning English. Okay, learning English. So I do like propose some what we can say, like a comment on how to improve or how to correct the wrongly sentences made by student. Okay, so starting from that, I move on doing some research on natural language processing, and currently I focus on sentiment analysis because I have few postgrad student, PhD student that are doing sentiment analysis. In fact, I have a PhD student from Indonesia. There are two, okay, now doing a PhD in sentiment analysis. Okay, let's move on. Okay, I will start with to let you know what are the application that basically we are using now that related to NLP. Sometimes we aware, or maybe sometimes we do not aware. Okay, so I would like you to get the idea. Okay, this is actually the NLP application. Okay, we start from the very basic grammar and spelling checker. Okay, this is a very basic. Normally when let's say you use Microsoft Word or other word processor, Microsoft provide us the grammar checker and the spelling checker. So this is the example of natural language processing application, because of the system will try to locate our error, the error in our sentences, and also the error in our spelling. Okay, so this is the basic. Then we move on. Machine translation also one of the basic application, even though it's become more sophisticated, become more robust. Okay, but yeah, machine translation is one of the oldest application that people start when the natural language processing actually comes in this world. Okay, so here is the example of Google that I use Google Translate. Okay. Okay, and then chat box. Okay, chat box and also visual assistant. This also an NLP application. Okay, the example here that I show to you is Asia, but I think I have checked before this. Now no more like this. The chatbot is now different. Okay, so but this is example of NLP application. Okay, this is one that my student like. Okay, sentence paraphraser. Okay, because sometimes yeah, student, okay, when they do assignments, right, I always say, okay, you cannot copy, you cannot plagiarize. Okay, so I introduce them. Okay, this is one example that you can use, okay, to paraphrase your sentence and to make it to start to just beginning. Okay, sometimes maybe you do not know how to write a sentence, you have a copy but you want to modify it. Okay, you can use this one. Okay, so this there are quite many. Basically Quillbot is one of them, and paraphraser. Okay, so this one, but the thing is paraphraser here, what you can say, how the system basically make it your I mean that paraphrase your sentence without changing the meaning. Okay, they use different words, okay, but the meaning is still retained. Okay, so this one, sentence paraphraser. Okay, and then email reply suggestion. Okay, this is one of not really a new, but is available right now in the email. If let's say we use Gmail, okay, or you use Microsoft email, when you have email, suddenly it will give this options to reply. Okay, so if you look at these two, okay, the suggestion is different. Okay, they don't have use the same suggestion because they will try to understand the content of the email. Then from that they will suggest the appropriate reply for that particular email. Okay, so for example, the first one here, so you can see that someone, okay, this guy, something happened, and then the suggestion will be, okay, no worries, thanks for update, great news, and so on. Okay, and then the other email also, okay, they have different kind. So how do the suggester being given? Of course, they will read the email and try to understand Okay, understand the email. Okay. Okay, so this is one of it. It's really good. Sometimes, if let's say we are on the go, for me, for example, sometimes my student email me on the go. I don't have to write down. I just click something like okay, receive, and thank you, and so on. Okay. Okay, so this is one. Okay, this one is in technical we call like language model, but this is something like next word prediction, meaning that when you type something in, let's say, Google, it will display what are the possible words after the current word. Okay, so this is a concept of language modeling. Okay, this is the one that actually has been practiced, has been used by ChatGPT and other GPT. Okay, they use a language modeling technology. So like here, okay, with the black background, when I type natural language, so normally the word that follow after natural language would be the popular one is processing, interaction, understanding, and so on. Okay. Okay, so that's all about the application. Okay, I hope that you may see. Okay, actually, okay, this is the one that they use. In fact, yesterday I found out in the Instagram, when you look at the live, I'm not really the Instagram, when you look at the live, okay, the live, something that I saw that there is a text that come out that something that we can reply to the live, I think. Okay, so that one also actually use natural language processing. Okay, so these are the content that I'm going to deliver. Yeah, it's quite many, but I tried to short it down. Okay, to make it less dry. Okay, less dense. Okay, so we have done the first one. Now we go to the second part, which is what is NLP. Okay, so this NLP basically, yeah, first, of course, NLP consists of 3 words: natural language processing. Now we go to natural language. Okay, natural language is the one that we say, okay, this is our natural language, okay, like English, me like speaking Malay, your Indonesian, okay, all is language, okay, whereby language, we have a certain words, not a certain word, a very big words, groups of words, and when we want to say something, we have the structure. Okay, we cannot just give any words because we have a structure or a grammar. Okay, meaning that the language that we speak follows the grammar that we actually know for that particular language. Okay, so that's about the natural language. Okay. So next, about natural language processing. Okay, so this natural language processing basically consists of 3 areas here. 3 areas: computer science, okay, artificial intelligence, okay, and linguistic. Computer science, because of the processing that we do in processing the language. Basically, yeah, we have a technique algorithm, okay, is a science, okay, and then we are using a computer, whereby the artificial intelligence, we refer to the because of understanding languages is hard. Okay, understanding languages is hard, and artificial intelligence actually, what they actually, we refer it as the capability of the computer that can do certain thing like human. Okay, so that's artificial intelligence. And linguistic, something about the language. In order for us to understand natural language, we need to understand certain level. There are a few levels, okay, that we have to know, okay, when we want to actually study or develop natural language processing application. Okay, so with the diagram, okay, that I give just now, basically this is the text that talk about what is natural language processing. Like, okay, a special field of computer science which is under artificial intelligence and involved with computational linguistic. Okay, and then okay, here NLP concerned with designing and building application and system that enable humans to interact with machine using natural language. Okay, so meaning that the mediation, okay, the intermediate, the languages is used as our interface. the communication between human and the computer. Okay, then the component of AI. Okay, the component of AI. Okay, so natural language actually is one of the component of artificial intelligence that are stated here. Okay, so this. Okay, then we go to the next one. Okay, the history. Okay, the history of NLP. Okay, so here the diagram that I took from this. Okay, basically there are three eras. Okay, in terms of the techniques that has been used to develop NLP, starting from symbolic NLP. Okay, this here symbolic NLP, as you can see the this one, and then followed by statistical NLP, then deep learning NLP. So for the symbolic NLP, basically we focus on the rule base. Okay, all the mathematical modeling, the handcrafted rules. Okay, focus on symbolic. Statistical comes machine learning, and then also where the data are available, especially like a big collection of data, corpus, that we say corpus that can be used, and then from the corpus we develop the model using machine learning. Okay, then deep learning nowadays deep learning, because of course with the technology of the machine and also the abundance of data that we have right now. Okay, so now moving to deep learning. So basically these are the techniques so far. Okay, the evolution starting from symbolic, statistical, and deep learning. Okay, let's see each of this era. Okay, first starting from 1950 to 1990. Okay, NLP started when Alan Turing published an article called Machine and Intelligence. So basically, Alan Turing, if you know about Turing test, Turing test whereby we develop a system, and then if the human communicate with the system, and then the human didn't know the one that he or she communicate with is a computer. In fact, they know it like communicate with a human, so we can say that the computer is intelligent. Okay, so that's the about Turing test. Okay, and then after that, in 1957, okay, now Noam Chomsky have developed Chomsky grammar. Okay, Chomsky grammar, where we can actually represent our language grammar in rules. Okay, in production rules. Okay, so the popular like context-free grammar, context-sensitive grammar, okay, or regular grammar. Okay, so that one we using production rules to represent grammar. Okay, so here Noam Chomsky in 1957 created a grammar called phrase structure grammar that translated natural language sentences into a format that is usable by a computer. Okay, so this one for under statistical NLP. Okay, and then one more in 1964, a chatbot called Halizah, okay, was developed by Joseph Weizenbaum. So basically, this chatbot, we call it Halizah, is actually designed to imitate a psychiatrist. And the responses that has been given by Halizah basically using template matching technique. Okay, so if you can see this sample of the conversation, okay, between Halizah and a human, okay, but you can see here when Halizah, okay, ask something, okay, let's say here, what's on your mind today? Please let me know your opinion. And then the human say about family, and then Halizah say, I see, okay, and then human say, I think Saze families is good, and then the Halizah said, what cause do you to feel that way? Okay, so you can see the responses is like natural. Okay, in fact, they are use template matching because of they have a template. Okay, if the question is like this, and then the rest of responses will be reply like this, some kind of this template. Okay, so this is also one technology that you can see. You can say that communication can be also quite natural, okay, here using Halizah. Okay, so that's about statistical NLP. Then we move on. That one is symbolic. Now we move on statistical, okay, between 1990s to 2010. Okay, the reason why statistical here, basically because of data are available. Okay, data are available, and then they can use data and we create a model based on the data, or we can actually see the trend in the data. Okay, so here like statistical inference consists of taking some data generated in accordance with some unknown probability distribution, making inferences and deriving conclusion from the data. Okay, so in this time, basically machine learning has been machine translation. Actually, one of the success is statistical machine translation. Okay, okay. Then we move on. Okay, so this is example of developing NLP using it can be like statistical, okay, or it can be modeling. Here basically we focus on the machine learning, or in fact we also can use symbolic, okay, for this. So here with the growth of the web, increasing amount of raw data has become available, and that's why research, okay, increasingly focus on machine learning algorithm for language processing. Okay, then we move on to the third era, 2010 until now, 2020. The drawback of statistical method, basically because of they require elaborate feature engineering. Okay, meaning that you need to extract features. Okay, when you do machine learning, you need to extract features from the data. Okay, so meaning that quite detailed on that area, feature engineering. So when it comes neural network, it's actually have overcome that's a problem. Okay, and in fact, when we use neural network, and in fact now more powerful computing system we have now, so it is possible to develop the NLP. So the machine translation that we call it neural machine translation. Okay, here emphasis the fact that deep learning based approaches to machine learning directly learn sequence to sequence transformation, obviating the need for intermediate step such as word alignment and language modeling that was used in the statistical machine translation. Okay, so deep learning here took over, okay, and become widespread in NLP. So due to result can achieve state of art result in many natural language tasks. Okay, so that's now deep learning basically that we are talking about. Okay, so this is the some architecture on how the deep learning, okay, on how to develop a natural language application using deep learning. We do have a document and then do a little bit processing, and then here all this the processing, deep learning processing inside here. Okay, so during this time, basically 2010 to 2020, you maybe heard about word to vec, glove, fast text. Okay, so because of these are called pre-trained word embedding. Okay, pre-trained word embedding meaning that a lot of words, okay, document has been trained, okay, to see the semantic relation, okay, among the words, okay, among the words. So meaning that when we train a document, okay, let's say one document, okay, they will try to see this word, what are the possible semantic related to this kind of word. Okay, as you look at this diagram, okay, there are three, okay, you can see three groups, okay, three groups whereby the green, okay, the green color, basically the words that related to positive, okay, positive sentiment, okay, like, okay, amazing, very good, terrific, okay, so all these words basically are similar, or you can group as them in positive, okay, positive value, whereby in the red colors, okay, mostly on the negative values, okay, mostly on the negative values, and the blue one basically just a neutral words. Okay, so with this word embedding, basically they are able to represent the words in this kind of representation. Okay, so that word embedding. And then one more thing about pre-trained language model. Okay, pre-trained language model, something that maybe you heard about BERT, okay, BERT here, bidirectional encoder representation, and GPT, generative pre-trained. Basically, these two are pre-trained language model. Okay, so pre-trained language model basically is like pre-trained word embedding, but they have more, because just now when I mentioned pre-trained word embedding, they only cover the semantic representation, whereby in this pre-trained language model, beside the semantic, they also have the context. Okay, the context meaning that there are certain words that is used differently in different contexts. Okay, so I will show that to you later on, okay, when we go to one topic under NLP. Okay, so starting from 2018, where GPT-1 actually created, okay, where they are able to do text summarization, name entity recognition, sentiment analysis. In fact, you can, when you use ChatGPT, you can just ask question and ChatGPT will reply you. Okay, they can, you give, let's say you want to create an email to certain person, you just ask the ChatGPT, please create me an email, and then it will create the email for you. In fact, like an essay, okay, I remember that my daughter wants to write an essay about my mother-in-law's, okay, passed away. So ask ChatGPT to write it down in, let's say, 300 words, and it's, yeah, they can prepare it. In fact, in our national language, like in Malay or Indonesian, they can actually have, but of course you need to read back, because there are certain that not really natural, the word that they use. Okay, in fact, ChatGPT, we can use it as like we learn together with ChatGPT. We do not use that to solve our problem, but we learn together. Okay, we get that output from ChatGPT, we look back, we revise, and we check whether it is true or not. Okay, so that's about the era. Okay, so this is about the starting from birth. Okay, so there are many more basically that has been developed. Okay, you have Elmo. Okay, and there are here, okay, so many, the Roberta, SLNet, all about pre-trained language model. Okay, and nowadays, like we have ChatGPT is GPT-3, and then now we have GPT-4. Okay, the Ernie basically Baidu from China. Okay, from China. Okay, so all these pre-trained language model that we can actually use it for our purpose lah. Okay, so this one is the chronology. Okay, based from the one that I mentioned just now, the chronology starting from Alan Turing 1950 to 1960 plus. Okay, we have Halizah, and then we move on to 1980. Okay, then now in 1990s, okay, machine learning approaches become popular. Then in 2010, neural networks. Okay, neural networks. And in, let's say, in 2015, okay, Google Translate introduced neural machine translation to improve the quality of translation. Okay, then now, okay, from 2016, where GPT-1 released, okay, by OpenAI. Okay, and then okay, what GPT-1 means actually is a model, okay, pre-trained language model that actually use unsupervised learning, which is it is able to generate human-like text. Okay, and then Google also have come out with a pre-trained language model. It's called BERT. Okay, and then after that, in 2019, OpenAI improved, okay, GPT-1, now GPT-2, focus on generate highly coherent and realistic text. Then 2020, GPT-3, okay, GPT-3 is the third generation of GPT, okay, meaning that more data, okay, larger data has been used. Okay, so this GPT-3 is able to generate text, answer questions, okay, perform other language-based tasks, okay, in a way that others is different from, okay, human-generated text. Okay, and then ChatGPT was released where people can use, okay, for our purpose. Okay, and then now a new one, GPT-4. Okay, GPT-4 is a large-scale multimodal. Okay, this GPT-4, the advantage, meaning that beside text, generating text, GPT-4 is able to explain about images, meaning that accept images and explain about images. Okay, so this is from OpenAI, but other companies like Microsoft also have something like this pre-trained language model like Copilot, okay, and others, okay, like if you had heard Stable Diffusion, DALL-E, all these is really something like about this, where they're able to perform natural language applications such as translation, summarizing, okay, paraphrasing, okay, so in one software. Okay, so that's about the history. Okay, now we go to the components of natural language processing. So this component, okay, there are two components, natural language processing, generation and understanding. Okay, generation is the one that has been done, okay, for is that, let's say, when we look at past, present, and future, is the one that has been done. That's why when I was doing my master last time, this generation is quite popular. So that's why I focus on this area, where this generation basically we develop a system to generate a text, okay, like machine translation, that's generating text, generating human language, okay, human language, whereby natural language understanding is slightly harder. It's harder because you need to understand the text. You need to understand the text for further processes, meaning that in order for you to summarize a text, of course you need to understand what actually has the topic has been discussed in the document, and then after that, then you can summarize it, okay, in, let's say, 100 words or so on. Or if, let's say, you want to translate the text, also you need to understand, and then we can translate to other languages with the same meaning. Okay, so understanding this natural language involves several level, okay, okay, that I will actually explain it after this. Okay, so there is one video, if, let's say, if yeah, maybe we can watch. Okay, I try. Okay, just now forgot whether I include the audio or not, but please inform me if you can't hear the voice. Okay, it's not so long, I think about 3 minutes or so, but yeah, it's just about between natural language processing and natural language understanding. Okay, let's start.
Hey Siri, what's the weather like today?
Can you hear it?
It's currently partly cloudy and
Yes,
Okay.
can hear it.
natural language processing. How I can talk to my watch, my phone, or my smart speaker, and how all of those things can talk right back. Let's break it down. We've got NLP, NLU, and NLG. Now, often people will use these terms interchangeably, but that is not quite right. See, in reality, natural language processing is made up of natural language understanding and natural language generation. It all starts when NLP turns unstructured data into structured data to be analyzed with NLU. NLU helps the machine understand the intent of the sentence or phrase and is used in profanity filtering, sentiment detection, topic classification, entity detection, NLU is used along with search technology to better answer our most burning questions. In traditional natural language techniques, the question is pulled into the graph structure that deconstructs the sentence the way you did in elementary school. And newer techniques use deep learning. Deep learning helps the computer learn more about her use of language by looking at previous questions and the way you responded to the results. Once the machine totally understands your meaning, then NLG gets to work generating a response that you'll understand. Hey Siri, I see a silhouette of the land. Scaramouche, Scaramouche, will you hear the fish echoes? It's like very, very fast. Galileo, Galileo. For more information on all things AI, subscribe to this.
Okay, so that's about the component, okay, of natural language processing. There we have NLG and NLU. Okay, so let's move on. Any questions so far? Oh, sorry. Okay. Then, okay, we look at the levels of linguistic processing. Okay, so here, what I mentioned just now, in order for us to understand, so we need this. Okay, yes? A question? So, any questions so far? No. Okay, okay. So we proceed, okay? Think no. Yep. Okay, so now we go to levels of linguistic processing. So basically, when we wants to develop, okay, the natural language processing, we need to understand this level about how language is processed. Okay, there are 6 levels. Okay, that are here: phonological analysis, okay, morphological analysis, syntax analysis, semantic, discourse, and pragmatic. Okay, so moving down is harder. Okay, so meaning that starting phonological is simple, followed by morphological, and so on until the 6th level pragmatic analysis is become harder and harder. Okay, so we look at one by one. Okay, phonological analysis. What is all about is a study. Okay, to actually study of the speech sound. Okay, speech sound, we call it as phoneme. Okay, the processing of speech sound into its basic unit called phoneme, and how are words pronounced, okay, in terms of sequence of sound. Okay, so if you refer to like a dictionary, okay, that you will see after the word there is certain symbol, okay, with a hash, okay, that's represent the phoneme or how the word is pronounced. Okay. Okay, so that's a study of phonological analysis. So when we actually want to do speech processing, okay, where our input is speech and our output also a speech, we need to first focus on this, the phonological analysis. So you need to know which phoneme actually that represent a certain word and so on. Okay, so that's about the words pronunciation. Then we move on to morphological analysis. Okay, so this morphological analysis basically of the study on the word itself. Okay, the word itself, how the word is, the structure of the word and how the word is formed. Okay, so this one, the words, because sometimes words, okay, you have suffix and prefix, isn't it? So that's about the study of the words, morphological. So the morphology basically is a word. Okay, so moving on to syntax. Okay, now we have words. Okay, so the combination of words become a sentence. Okay, so become a sentence meaning that based on the correct syntax or the correct grammar. Okay, so this syntax analysis basically study of how we combine words to produce the correct sentence. Okay, so in other way, this is about the study of the grammar of a language. Okay, then after we know the sentence is correct, the structure is correct, then now we want to understand, right? Understand the sentence. Okay, so now we go to the meaning, semantic, word meaning, the how each word, the meaning of each word affect the whole sentence. Okay, or how the whole sentence has been interpreted into different situation, okay, or different meanings. Okay, so that's about meaning. Then we move on to the discourse analysis. Okay, so discourse analysis now, how we affect, there are, okay, sentence, we have many sentence. So how first sentence affect to the second sentence, okay, how we interpret first sentence, and this one will actually influence the second sentence. Okay, so that's about discourse. Okay, then move on to pragmatic. Okay, pragmatic is a big, okay, is talking about situation, context, okay, how this sentence, okay, one sentence is used in different contexts, okay, in different situation. Okay, so let's see again on this, okay, in the next slide. Okay, so phonology, okay, how do we pronounce, okay, so like you can see here, table, okay, so this is the pronunciation, okay, for the word table. With that, okay, the one that underlined here, /t/a, okay, that's the phoneme, okay, the phoneme. Okay, then move on the morphology. Okay, morphology is the study of words. Okay, so let's say we have this word, okay, pemprosesan. Okay, pemprosesan actually is come from the word process. Okay, the word process. So the word process is a stem. Okay, the root is a stem, and then when we actually combine with suffix, okay, affixes. Okay, affixes is perm. Okay, perm is a prefix. An is suffix. So when we combine it, it's become a new word, pemprosesan. Okay, so morphemes is like perm, process, an. Okay, so how do how actually we we combine it, make the right word. Okay, for example here, okay, like the word stop. Okay, with unstop. Okay, we have unstop. Okay, meaning that the first column here like something like the prefix, okay, or like un and none, non-stop, and then the third column can refer to like suffix, okay, stop, stopping, stopped, okay, stoppable, okay, and in fact, if other words that we combine with this stop, like door stop, okay, stop gap, stop over, stopwatch, okay, all different, isn't it? Like backstop, show stop. Okay, so with the one word, okay, when we combine it may get different thing. Okay, then we move on to syntax. Okay, syntax, how do we study the correct structure of a sentence, meaning that a combination of the words that makes a correct grammar or a correct sentence. Okay, so for here, like the cat chased the mouse. Okay, so this individual words has its own category, or we call part of speech, like the is categorized as determiner, a cat and a mouse, a noun, okay, chase is a verb, okay. So the combination of determiner and noun become a noun phrase, okay, become a noun phrase, and a combination of a verb with noun phrase become a verb phrase, okay, and then a combination of a noun phrase followed by verb phrase become a sentence. Okay, so this is the study of the syntax. Okay, so if let's say for the grammar checker, okay, normally we will the basic process, like if you use rule base, this is the grammar that we provide, okay, to check whether our sentence follow this structure or not. Okay. Then we move on to the semantic. Okay, the semantic, how the study of word meaning in language and how this meaning combine in sentence to form sentence meanings. Okay, so look at this, the sentence. Sherlock saw the man using binoculars. It can be interpreted in two different situations here. Okay, meaning that first one where Sherlock saw the man using binoculars, meaning that Sherlock using the binoculars see the man, okay, to see the man. Another one that we can interpret, basically, Sherlock saw the man whereby the man actually using the binoculars. Okay, so these two things different, isn't it? But based on the one sentence, okay, one sentence. So this one is called ambiguous, okay? A sentence that can be interpreted by several meanings is called ambiguous. So this ambiguous basically is the most challenge, okay, in NLP, okay, in doing application NLP. We human, we know, but is in order for the computer to differentiate is quite hard. Okay, so that's semantic. Then we move on to, okay, this another one, okay, another word. Time flies like an arrow. It can be interpreted in three situations here, whereby the first one, okay, it's really like, yeah, it's very fast. Time is very fast. This is the one, actually, this is the one that we meant, for example. Then the second one, something like time flies, okay, the flies that with the time, with the watch, okay, like an arrow. So meaning that love arrow, okay, that one also can be interpreted. And the second one is time flies like an arrow, okay, time flies, okay, like an arrow. So this one, times, okay, flies like an arrow. See this one. Okay, so this semantic. Then we move on discourse. Okay, discourse where the study of the how immediately preceding sentences affect the interpretation of the next sentences. Okay, look at this sentence here on the left. Okay, Victoria Chan, CFO of Megabucks Banking, saw her pay jump to $2.3 million as the 38-year-old became the company's president. It is widely known that she came to Megabucks from rival Lok Sabak. Okay, so here, how do we understand? Okay, especially how the computer, we as a human, we know, but how computer know that her basically referring to Victoria Chan, and the 38-year-old also referring to Victoria Chan. The company's president also Victoria Chan. And then in fact in the second sentence here, it, what is it referring to? And then she here, okay, she referring to Victoria Chan. Okay, so this is about discourse. Okay, so there are a lot of studies now, okay, nowadays in for this one, okay, about discourse analysis. Okay, more focusing on the pronoun, the use of pronouns in sentences. Okay. Okay, then the next one is pragmatic. Pragmatic is the study of how sentences are used in different situations and how use affect the interpretation of the sentence. Okay, look at these two scenarios. Okay, two scenarios. First one, Ali didn't have a watch, meaning that Ali forgot to wear his watch, and then he was afraid that he might be late to the interview, so he asked the lady next to him, "What is the time now?" Okay, so what do you think the lady answer? Okay, because he asked the lady that sitting next to him, "What is the time now?" Of course, the lady will answer, yeah, something like, okay, the date, isn't it? Okay, looking to the second scenario, okay, the lecture time starts at 9 a.m. in the morning, but student turn up at 9:30. So the teacher asks, "What is the time now?" Okay, what do you think the student answer? The student do the student say, "It's the 9:30"? I don't think so, right? Okay, because of it's something like sarcastic, okay, situation, okay, where the teacher don't want to actually ask, okay, to scold, but just saying something. Okay, what is the time now? Okay, so with these two sentences, it can be in reply by different thing. Okay, different thing. So this is pragmatic. Okay, where one sentence, the same sentence, but when you use in different context, different situation, the response will be different. Okay. Okay, so this is about the 6 levels, okay, for linguistic processing. Okay, so talking about the applications, okay, okay, these are the what we can say that the examples of the application, okay, like phonological analysis, automatic speech recognition, text-to-speech synthesis. Even though these two, automatic speech recognition and text-to-speech synthesis, basically not only using phonological, it's also use morphological, all this, okay, but I just want to focus on the speech itself, okay, how they process the speech, okay. And then morphological analysis, something about how you study about the word itself, okay, spelling checker, or we can also like we can use name entity recognition, okay, to identify entity in the document, okay. And then syntax analysis, grammar checker, okay, grammar, okay, to check grammar. And semantic, okay, so basically semantic, yeah, to study meaning, so like translation, question answering system, all. In fact, summarization and document similarity also you need to have to undergo semantic, okay. Discourse, okay, so these two, discourse and pragmatic, sometimes people combine it into one, okay, but I would prefer to separate it to 2 different level, so it meaning that the student can actually more understand. Okay, so like text summarization also, discourse. So this one also, of course, you need to undergo the prior, okay, the previous analysis, okay, before coming to the current one. And the document similarity, how do you check the similarity of the document? Okay, so this is the levels and the application, okay, NLP application that we can relate to. Okay, so we done by that, okay, levels. Okay, we have 4 more. Okay, I hope that you stay on. Okay, is there any big break or whatsoever that we can have, like 5-minute breaks, something, or we proceed? Okay, we just proceed, Miss Yunila. Okay, we proceed. Okay.
Yes, proceed.
Okay. Yeah. Sure. Okay. Developing NLP applications. Okay. Developing NLP application. Okay. So these are the standard process, okay, that we have to follow for developing NLP application. Okay. Of course, from the text, okay, we need to do processing. Okay. We need to do processing because text is unstructured. Okay, text is unstructured, so you have to make it structured. We need to do processing. We let's say the sometimes the sentences has like raw sentences, like they have many like spelling error or the use of emoticon, okay, something like that, that we need to actually remove, or because sometimes spelling errors you have to make it correct it, okay, and emoticon also maybe you can let's say replace it with what is the appropriate word to represent the emoticon, okay, and there are some symbols, okay, that not really important in the text, meaning that not really give significant influence in the text, okay. So once you pre-process, okay, then we extract the features, okay, extract the features. So there are several representation that we can use to extract the features from the clean text, okay. Then we can do model, okay, model development. So for the model development, you can use machine learning model, or you can develop your own, like you can actually like use rule base and so on. But here I focus on the machine learning, okay. And then after that, evaluation, okay. Evaluation is you, of course, we need to evaluate our model to see its performance, okay, to see whether our models perform well or not, okay. Okay, so that's the main thing, okay. It can be like 4 stages. Okay, let's go to it one by one. Okay. So these are the comparison between classical NLP versus deep learning. Okay, deep learning. So it's, you can see here like pre-processing. Okay, it here a main thing in the classical, or we can say machine learning, and symbolic NLP, and modeling is here. Okay, so whereby deep learning, you can see the processing is just a little bit, okay, on here. It's we can save on the time on pre-processing, but we're focusing on the process, okay, the main process, the learning part, layer by layer in the text, okay, in the text. Okay, this one. Okay, first we go to the first one, text pre-processing. Okay, so there are various tasks that we can do for text pre-processing depending on the nature of your text. Okay, if the text that you take from news, not much pre-processing that you can do, because normally news data, the sentences are all incorrect, okay, in correct or grammatical correct. Okay, maybe we can remove like numbers, punctuation, okay, and so on. Okay, but if the data you took from social media like Twitter, okay, yes, you need to do a lot, okay, a lot pre-processing. Okay, so it can, for example, removing punctuations, okay, removing punctuation, you remove numbers, and then stemming, meaning that you just extract the stem, the root words only, okay, the root words only, to reduce the number of column in our features file, okay, because less column processing would be faster, okay. And also lemmatization, okay, these two relate to each other, but the focus on stemming and lemmatization is to convert all the word like processor, pemprosesan, pemproses, okay, into one word, to process only, okay. So that's the main thing of this stemming and lemmatization. Part of speech tagging, basically to tag the word into its category for further process. For example, for name entity recognition, okay, where we have the text, you want to extract certain entities. Normally like reports, okay, reports on, let's say, crime reports. You want to know who are the thief, okay, who is the victim of the event, okay, when the time actually the crime happened, okay, where, okay, so that is tagging. And stop word removal, basically words that is not really influence in the text will actually remove, okay. If let's say you look at this one, this sentence. Text processing is an essential step in NLP that involves cleaning and transforming unstructured text data to prepare it for analysis. So the stop words removal, basically the one that is and, okay, it's not really, if you remove that, okay, is and in that, okay, for to, if you remove that, you still can understand the sentence. Okay, and then HTML text removal. If let's say you have HTML text in the data, so you can remove it. Okay, and then the main thing is tokenization. Tokenization is to tokenize each word. Let's say you have a sentence, you need to tokenize each word in the sentence into individual words. Okay, so that's about pre-processing. Then we move to the feature engineering. Okay, so feature engineering basically to extract the data, okay, to get something, to get a meaningful features from the data. Okay, sometimes it called feature extraction. Okay, feature extraction. So we normally, when we want to extract, we will represent the representation into a table or a vector. Okay, so let's see here, okay, the process. Let's say you have a data, raw data, you clean, okay, just now that we did, we pre-process, then we do extracting the features. Okay, so let's see what are the features extraction. There are two types. Okay, we call it word embedding. Okay, because of we represent it in tabular. Okay, in tabular. So one is frequency based and one is prediction based. Frequency based is the number in the table itself represent the occurrence, okay, of the word in the document. Okay, so there are a few here like back of words, okay, back of words, TF-IDF, I will give the long name after this, and engram. Whereby the prediction base, okay, this is the one that advanced, okay, a current one, okay, use two representation like continuous, back of words, and skip gram. Okay, these two representation actually under neural network. Okay, under neural network representation. So for those who want to know more about this, need to understand the fundamental of neural network. Okay, so let's look of this, okay, in a surface level, one by one. Okay, first like back of words. Okay, so this is the simplest technique to extract words, okay, to extract features, okay, from a text. So you extract the word and you convert it into numbers, okay, into numbers. So meaning that like it represent like how this particular word, how many times it is occur in this document. Okay, let's see this one. Okay, for example, you have the document here, and when you represent it in back of words, it's look like this. Okay, whereby you have the row actually is the number, the words, the individual words that occur in the documents. Okay, so this is the distinct word. Okay, you focus on the distinct word, okay, that available in the document, and then the column here is represent the document. Which document? Document number. Okay, so for example, okay, let's say you have about 5 documents here. Okay, the word complexity basically occurs in document 1 2 times, document 3 3 times. Okay, document 4 2 times, on document 5 3 times. Okay, whereby in document 2 word complex is not available. Okay, it's not occurred. Okay, and then like algorithm here, okay, occur 3 times in document 1, document 4 and 5 occur 4 times. Okay, so that's how it is actually read. Okay, so by looking at this, we can see, for example, the occurrence shows that how likely the document actually talking about what topic. Okay, so for example here, if you can look at here, okay, algorithm occur more in document 4 and 5. So something like it mentioned about the algorithm, okay, something about that, okay, in document 4 and 5, whereby nothing in document 2 and 3. Okay, so that's about back of words. Okay, then the second type would be TF-IDF, okay, term frequency inverse document frequency. Okay, this one basically it's actually if you look at this one, this document, if you maintain all the word, okay, let's say the word is, it, in this list, you can see that this word occurs all, of course, occurs in all document, okay, occurs in all document, whereby the word itself is not really important, okay, it's not really important. Okay, so TF-IDF, what we do, it will actually decrease the value for all words that always occur. Okay, for example, like stop words here. Okay, stop words here. In TF-IDF, it will give low value. Okay, low value. And then for the rare words will become high value. Okay, high value. Okay, so this is what TF-IDF actually is done. Okay, so meaning that for TF-IDF, normally we do not remove the stop words. So when we do not remove the stop words, so we will get this kind of value. So for the stop words, for meaning that the words that always occur will become very small value, very low, and the rare words or the frequent words become higher than, okay, stop words score, okay, or values. Okay, so that's the TF-IDF. Okay, so for these two, back of words and TF-IDF, actually is a common, okay, nowadays they're used. However, it's only focused on the words itself, only on the words occurrence. It doesn't actually what we say that it doesn't concern on the semantic structure, the syntax, the sequence of the word, or the context that has been, let's say, the nearby words that has been used, okay, for that. So that's not actually focused on back of word and TF-IDF. So the prediction based word embedding basically focus on this, okay, focus on this. So for example here, these two sentences, this squad is ready to win the next Malaysia Cup match. And then the second one, this team is prepared to achieve victory in the upcoming MC game. Okay, these two sentences are different, isn't it? However, these two have same meaning. These two have same meaning. If we represent it in back of word and TF-IDF, these two would give different metrics, different vector. Okay. Okay. So so meaning that if we represent it into this prediction based word embedding, these two sentence will be located at the same place, slightly in the closer to each other. So meaning that it is similar even though it doesn't use the same word. Okay. Okay, so for example here, okay, this one, Ali is smarter than Ahmad and Ahmad is smarter than Ali. These two sentences different basically in terms of the meaning. However, when you represent it in the back of words, it gives similar values. Okay, it gives similar values. And then okay, so when it gives, so meaning that you can see that it's only focused on the occurrence of the sentence. Okay, it doesn't care about the meaning. Similar to the next these two things, the two sentences here. Okay, so for the prediction based basically focus on the semantic relation, okay, and also the context of the use, okay, the where the word used in what context. Okay, so for example here, the word, similar words in a semantic sense have smaller distance between them than words that have no semantic relation at all. Okay, so if you, let's say, have a word, something like mother, father, butter and ketchup. So mother and father will be grouped to one location, and butter and ketchup will be grouped to one location. Even though the word is not similar, but it's similar in the something that in the certain context, like family context. Okay, family context, mother, father, uncle, auntie. Okay, that's the words that always talk about really about family. And butter and ketchup is on about the food or let's say making making a cake, for example. Okay, so that's okay. So for this advanced or the prediction based, basically they are focused on this. Okay, the how the words actually has been used in certain contexts. Okay, so the word embedding, the one that I'm talking about just now, if you have heard about word to vec, glove, fast tag, okay, that's are the pre-trained word embedding. Okay, so this word embedding, we train it on large data set. Okay, and then you can use it for other tasks. Okay, other tasks, let's say, okay, you have word to vec, okay, and then you can use the word to vec for your data. Okay, to actually to do some for, let's say, sentiment analysis. Okay, so that's called transfer learning. Okay, meaning that we this word embedding has been trained on a very big data. Okay, and you can use your own data to fine tune the word embedding. Okay, where to use for your purpose, like for example yes no, for example text classification. Okay. Okay, another one, features that we can extract, okay, is called stylometry. Okay, stylometry is focused on this application: plagiarism checker, forensic analysis, author identification, okay, and so on, genre application and genre application and music lyric. Meaning that it look at the style of your writing, if let's say, okay, in order to know the author of a certain text, okay, the author of the certain text, so they look at the style of the writing. For example, normally what words that you always use, okay, do you use like first person pronoun, or you always use second person pronoun, or what are the certain phrase that you always use? Maybe certain people will always use as far as I'm concerned. So that is called style. Okay, so that also can be actually we can extract, okay, to get the style of the author for that particular text. Okay. Okay, so that's about feature engineering. Then we move on to model development. Okay, model development, what are the models, okay, that we use? Okay, so when you have the feature, okay, using machine learning, okay, we can choose certain model. Okay, for text, normally, okay, we can use knife-based, support vector machine, logistic regression, okay, to use, okay, to actually learn from the features. Okay, and then recent algorithm in deep learning also you can use. Okay, okay, so this is the model development. Okay, then once we develop the model, okay, then we evaluate. Okay, we evaluate to see the performance of your model, okay, or your system. So normally you have a test data that you use to actually evaluate your model. Okay, and of course your test data must be also processed and extracted the feature similar like your trained data. Okay, okay, so these are several metrics, okay, that you use: accuracy, precision, recall, F-score. Normally for this metric is for task classification, okay, sentiment analysis, okay, okay, machine translation, okay, metrics like text summarization, they use different. Okay, they use, let's say, raw or blue. Okay, that one. Okay, because text summarization requires of course requires human to check, okay, the coherence of the text. Okay, so this is the common metrics that we use for common NLP application. Okay, done. Okay, we have 3 more here. Okay, inshallah we can complete by 12 o'clock. Okay, NLP dataset and libraries. Okay, if you don't have data that you can get it from this data set, is all data that if let's say you cannot crawl it on your own data, okay, you can go to this, okay, website to crawl the data, to get the data. Okay, so let's say the common one is Kaggle. Okay, there are many data that you can actually download. Okay, if you want, let's say here I type text, so it will display some of the text data that we can use. So if you click on that, you can see what are the content of the data. Okay, and in fact in Kaggle also they give some code, okay, sample code that others have been used to process the data, so you can see the code, okay, especially the Python code. Okay, another one is UCI, okay, machine learning repository. This is this one is quite old than Kaggle. Okay, so this one also that there are some data that you can get, okay, or you can download. Okay, for my class, natural language processing, I use Python, okay, to let the student explore developing NLP, and I mainly use the library, NLP libraries in Python, which is NLTK, which is Natural Language Toolkit. Okay, so in my class, I'll ask students to explore this NLTK to find out what are the functions that's available to for processing text. Okay, and also other libraries such as Sparsy, okay, here text block, okay, okay, spelling error, Stanford Core NLP, and GenSim. Okay, GenSim and also TensorFlow for deep learning. Okay, deep learning. Okay, if let's say you don't want to focus on the coding, we can use the NLP API, but this one is actually we need to pay, okay, subscribe. Okay, mostly like companies, they have money, they subscribe these services, okay, where we can use its services to do the NLP application. So this NLP API basically is a machine learning model for analyzing text. Okay, so you can use it. You can just use the data and let's say you want to do like text summarization, for example, or text classification. You just upload your data and then it will do for you. Okay, so for some of the example here, Google Cloud NLP, IBM Watson API, iLearn, Monkey-learn, and so on. Okay. Maybe we can try. You can use the free trial for to explore. Okay, but after that you need to subscribe. Okay, when you want to use the service. Okay. Another one here, Hugging Face, which is this is a one-stop center also that you can use for not only NLP, for artificial intelligence application. Okay, this one it actually share a lot of data and also models that you can actually just use it, okay, to develop your own application. Okay. So so here Hugging Face is a large open source community that builds tools to enable users to build, train, and deploy machine learning model based on open source code and technologies. Okay. So here, okay, I give example. Okay, this is if you go to this website, huggingface.company. Okay, so you can see here, okay, beside natural language processing, the model that you can you can download the model, and then here you can see text classification, token classification. Okay, so when you click at task classification, it will list out what are the model that has been trained to do this task classification. So meaning that you have your own data, you can just use the model to actually train your to fine tune your data to create a new model for your system. Okay. So this one, NLP, and okay, you can see here, computer vision also you have, and if you scroll down, there are many more. Okay, and this is the model. Okay, and then data set. You also have data set here. Okay, not only English, other languages also available. Okay, so this one. So maybe you can explore. Okay, if you haven't, maybe you can try. Okay, try explore. For example, here that I try in my Google Colab. Okay, of course, first I need to install its library transformer, and then I import the transformer. Okay, and then I want to use sentiment analysis. Okay, sentiment analysis. Just call it pipeline and sentiment analysis, and then I just give this sentence. Okay, give the sentence, then it will classify it into positive or negative. So let's say the sentence, we are very happy to have you as our guest. So it is classified as positive. Okay. And if let's say you give two sentences here, okay, as you can see, the first one is positive and the second one is negative. Okay. And if you want to use the model that available in Hugging Face, okay, you can choose. Okay. For example, here I use Distilled Uncase Fine-Tune SST English for sentiment analysis. Okay. And then you can see so you can actually do the process here. Just call and then just call the model and then ask the model to classify the sentences. So this is examples. So there are many more in the website, okay, in the internet that you can refer to. Okay, challenges. Okay, the challenges of challenges in developing NLP. Okay. I actually separated into two, data related and understanding related. Data related is about low resource languages. Okay, of course. English now is available, is quite stable. They mostly application, okay, focus in English, but how about low resources like my language, our language, okay, bahasa Melayu, bahasa Indonesia, okay, that's considered low resource language, meaning that not many application actually has been focused on that languages, okay, and also large or multiple documents. Sometimes we cannot process longer context, isn't it? And then quite expensive to obtain that multiple documents. In terms of understanding related, okay, I mentioned about ambiguous just now, same word, different meaning, okay, and also synonymy, meaning that different word that has same meaning, okay. Co-referent resolution, this is the one that we need to focus on discourse and pragmatic analysis, and last one is the irony and sarcasm, okay, the one that only human actually understand that. Okay, ambiguity. Okay, ambiguity where many words have many meanings. Okay, for example, the word I make her duck. Okay, I made her duck. Okay, of course you can interpret in many ways here. I cook a duck for her, or I cook the duck she owned. Okay, this one is you cook. Okay, you cook the duck. Okay. Whether you buy it, the duck in the market, or that person, she own, you cook the duck. The third one, I caused her to duck down. Okay, that one is the action. Okay, verb. I caused her to duck down. It can be interpreted like that, or you can for the fourth, I magically turn her into a duck. Okay, you turn her into a duck. Okay, that one. And the last one, I make a calf duck she has. Okay, okay. So that's the ambiguous. These challenges, okay, in NLP. Synonymy, different word, same meaning. Okay. For example, big and large. Okay, big and large is a synonym. Okay, yeah, the meaning is similar. However, you cannot use these two. You cannot interchange these two sentences in these two words in one sentence. For example, my big sister and my large sister is not similar. Okay, my big sister and my large sister different. Okay, so you cannot simply change the word big with large. Okay. Then co-reference resolution. Okay, this is about the conversation, okay, between user and system. How do the system understand what the user question? Let's say, for example, I would like to open a fixed deposit account that the user asks. The system will say, for what amount? Okay, for what amount? And then user said, make it for 800. So the word it here, is it, what is it stand for, referring for, is it? So for here, it refers to deposit account. And then for what duration, asked by the system. So the user say, what is the interest rate for 3 months? So the system asks answer 6%. So that the user say, oh good, then make it for that duration. So it refer to what? Okay, is it refer to the 3 months or what? Okay, so this is called co-reference resolution. Okay, and okay, so lastly, okay, maybe about NLP application. Okay, for NLP application, there are various here. Okay, I don't think that I want to talk all. Okay, I think all of you knows about it. Machine translation, text classification, sentiment analysis, document clustering, text summarization, okay, question answer system or chatbot, text similarity, speech recognition, and text to speech. Okay, so I will pick some only on that to discuss. Okay, machine translation, okay, is okay, you know, to translate from one human language to another human language. So these two, okay, the first one is the one that I use, Google Translation. Okay, this is from English to Indonesian. And the second one here, the translation made by ChatGPT. Okay, so if you look at, there is a certain different words. Okay, like here, like, okay, like in Google Translate, Victoria Chen, CFO Megabyte Banking, melihat gajinya melonjak menjadi 2.3 juta, isn't it? But here in ChatGPT, melihat gajiannya melonjak menjadi. Okay, so there is certain word actually. Okay, but it still retain the meaning. Okay, retain the meaning. Okay, text classification. Okay, to classify the text into certain group. Okay, the most common is email filtering. Okay, for email filtering. Okay, to classify whether the email is a spam or not. Okay, so that. And okay, this is one of my student do final year project abstract classification. So we have a model to read the abstract and classify it whether the project is artificial intelligence or under software or under multimedia or under network. Okay, so that's considered classification. Sentiment analysis nowadays a most popular system, okay, where has been used by companies to actually to study the acceptance of their product, okay, or let's say to when we want to watch a cinema, maybe you look at the review, okay, whether the movie is good or not, okay, that one. So this is classified under sentiment analysis. A chatbot, okay, where we can communicate with a system about something, or let's say okay, like chatbot, okay, normally the company will actually provide this, okay, because they want to replace the normal person, because chatbot can be actually work 24 hours. Okay, so that text paraphraser here, okay, that I actually showed it before, okay, text paraphraser. And okay, the last one here about the text recognition, okay, speech recognition and text to speech, okay. Yeah, if you use iPhone, you have Siri, right? If you use, let's say, Android, you can use Google, isn't it? We can, while driving, you can ask, let's say, hey Google, can you locate me to this location? Or you can say, hey Google, open Google Map, and then it will open it for you, and then you can say, okay, I want to go from here to here. So it can understand, okay, and then it can open Google Map and actually locate the destination. And also Amazon Alexa is one of the virtual assistant, okay, that can help you, let's say something that about your diary and so on, okay, that's about Amazon Alexa. Okay, so these are the just one video about Amazon Alexa, and I think that, okay, this is the last, okay, there is one more, okay, ChatGPT. So here, ways to use your Echo Show.
Want to learn how your Echo Show can help you? Here are 5 cool things to try with your display. Cool like you or cool like me? Cool like me. When you're cooking and your hands get messy, Alexa can guide you with step-by-step recipes. Alexa, show me a brownie recipe from the Food Network kitchen. Okay, for brownies, here are a few recipes. Alexa, start the second recipe. Alexa, pause. All right, Alexa, next step. Now you're not going to need as much fun. Alexa, what's your favorite flavor of ice cream? I really like mint microchip. I mean, mint chocolate chip. Want to get your groove on? You can get all of your favorite songs on your Echo Show. And play music on other connected smart speakers around your place. Just say, Alexa, play Scout's favorite playlist everywhere. The playlist. Scout's favorite playlist on Amazon Music, now playing everywhere. Did you make a playlist for your dog? I sure did. Scout loves rock. He's probably barking along upstairs right now. It's your Echo Show like a digital picture frame. Just pick some of your favorite photos from Amazon Photos. To display your photos, say something like, Alexa, show my vacation photos. Here's your album, Vacation. That's not some slideshow you have there. I like to traffic like it's hot. Killer photos with the background. Oh, Alexa, set this photo as my background. Okay, setting to home background. And that is a nice shirt. Hey, thanks. I was really hoping you were going to say that. I got one for you too. Oh, great. I'm so excited to put it on. When your hands are full or you can't get to the door, Alexa can help show you who's there. Just connect Alexa to the Ring video doorbell. Someone is at the front door. Alexa, show the front door. Okay. Hey, it's Mark. Mark, he's 4 hours early. I haven't finished decorating or wrapping his gift yet. Alexa, talk to the front door.
Knock, knock.
Who's there?
Mark.
Mark who?
Mark your calendars, because it's my birthday.
I do love a good knock-knock joke. Your Echo Show is also a great way to keep in touch with family and friends. Alexa, call Mom. Hey, Marissa. Oh, hey, Mom. I was just showing them how to do a video call with Alexa. Oh, that's nice, but I'm actually just headed out for a dinner party. I'll talk to you later. Mom is so cool. Some of the fun things you can do with your Echo Show. Go give it a try. And be sure to watch more of our helpful videos. Want to learn?
Okay, so that's all. That's about the Alexa. Okay. Next we go to the next, which is ChatGPT. Okay, ChatGPT. Okay, so nowadays we talk about ChatGPT. Okay, talking about ChatGPT. So actually ChatGPT developed by OpenAI. Okay, it can be like it is like AI chatbot. Okay, that we use natural language to create human-like conversation. Okay, conversation, and then you can use a lot of things, okay, in this with ChatGPT. Like you can ask question, okay, get some answer, respond, or you can ask ChatGPT to do summarization for you, or in fact you can ask the ChatGPT to actually give you the Python program, okay, let's say if you want, okay. So that's so this ChatGPT is a form of generative AI. Okay, so meaning that generative AIs, meaning that refers to deep learning models that can generate high quality text, okay, and images or other content-based data that they were trained on. And of course, this GPT has been trained on a massive amount of data. Okay. So GPT means generative pre-trained transformer. Okay, generative pre-trained transformer. So meaning that the data that has been used, that has been trained, is very, very large. Okay, very, very large. Okay, so this is just a sample that I asked ChatGPT what is NLP, and it give me these responses. Okay, and then I asked ChatGPT to summarize the response into, let's say, 150 words, and it give me this one. Okay, so within 150 words. Okay, so yeah, nowadays a lot of AI tools available, and yeah, of course we if you don't use it, we fall behind. But of course, when we want to use it, we use it ethically. Okay, use it ethically, meaning that not to just asking to do your work, but together, you and that tools together doing. Okay, okay. So that's all about NLP. Okay, I hope that you get something, okay, on this topic. Okay, so I'll open for any questions. Okay, thank you very much. Okay.
Okay, well, thank you very much, Dr. Halizah, for the
Yes.
great presentation. Okay, before we start the creation, I put a few points in the session. Yes, natural language is one developed and provide through natural use and communication. There are two components of NLP, and natural language generation and natural language understanding. And for developing an NLP application, there are text pre-processing, feature engineering, model development, evaluation, and deployment. Okay, well, now we start a Q&A session. Please, we start with raise hand question. Please, Miss Dian Rospita. Yes, Miss Dian Rospita, you can ask directly to Dr. Halizah, please. You can open mic, please, Miss Dian Rospita. Yes.
Okay. Thank you, Miss Yunila. Sorry. Can you hear my voice?
Yes, yes. I hear.
Yes, we hear.
Okay. Once again, thank you, Miss Yunila, for giving me this opportunity. I'm Dian, and I'd like to ask Dr. Halizah about our interesting topic today. Okay. We have discussed about BERT and GPT in natural language processing, and we know about the abundance of NLP products in multilingual settings. I've been thinking, how would the application of natural language processing be if used to assist people with language or speech disorders, such as autism or aphasia? I just want to ask your opinion. Do you think natural language processing application in this area are becoming increasingly important and have the potential to develop further in the next 5 to 10 years? I think that's all. Thank you.
Okay, good question. Thank you very much. You asking about people like speech aphasia, isn't it? How can NLP help them, right? Isn't it?
Yeah, that's true.
Yeah. Okay, if you look at the speech processing, nowadays the the quality of the speech. Basically, they are able to recognize various speech. Okay. In fact, like, okay, I remember last time, 20 years ago, when I first like joined working in the university, I remember that I used one speech processing system. Before I need to use that, I have to train my voice, meaning that I have to record my voice. Okay, they give me a list of documents. I need to say it. Okay, say it loudly, and then from there they develop the engine, and then after that I can use the system. But nowadays, the speech, the processing that they did is now robust. Okay, it's now robust, and I think, okay, in next 5 years they are able to help also the people like speech aphasia and so on. Okay, and in fact, I and my member did involve one project, okay, on speech aphasia, whereby we develop a small system where the people with this speech disorder can use to actually practice their pronunciation. Okay, pronunciation. So by actually saying some words, and then the system will try to detect and whether and will respond whether it's correct or not. Okay, that one also is good. Okay, so I think it will help. Okay, it will help that people that with that situation later on. Okay, that's my actually my opinion. Okay, is that okay, Dian?
Okay, thank you, Dr. Halizah, for your answer.
Okay, thank you very much, Ms. Dian Rosbita, for the question. The next question, is there any question from our participants? So you can ask directly to Dr. Halizah. Okay, please, Mr. Ras.
Okay. Thank you for the opportunity that Miss Yunila gave. So first of all, let me introduce myself. My name is Axeliano. I'm from Informatics 21. Thanks for the lecture that you give to us. It's very exciting and open up about the NLP process. And I want to ask about this is how if we insist to have some model into NLP that you said in lecture, there is some NLP model that we can use like KNN, neural network, logistic regression, SVM, naive Bayes, and many more. So what I want to ask, what is the best model now for now? And then is there any threshold if we train this model into some big data, will be like more too accurate? And what is the MEE of mean absolute error for its model? Thank you.
Okay. Okay. So for I just now I mentioned that to develop NLP application, one we can use like machine learning. Okay, machine learning. Meaning that you have your own data. Okay, and then you develop a classifier. So machine learning mostly, okay, from the research that I actually go through with my student, mostly the model that the machine learning model that quite popular for text is naive Bayes, SVM, linear regression. Okay, that one. Okay, so that that's you can develop the model, and the mean error, okay, meaning that in terms of the accuracy, isn't it? Accuracy. So normally, of course, accuracy, if nearly 200, that would be the best. That would be the best. But mostly we accept like 90%, okay, accuracy, that will be fine. Okay, that will be fine. Meaning that if you have 100 data, 90%, meaning that out of 100 data, your model is able to detect or do the correct way in 90 data. Okay, 90 data. That's about that. Okay, that's using machine learning. But nowadays, since we have a lot of pre-trained language model, okay, because of the language model has been trained on a very big data, okay, on very big data. So it's already trained, meaning that is okay. Remember like this, you know how to riding a bicycle. You learn on riding bicycle, isn't it? You know how the technique to cycle. Then after that, you want to ride a motorcycle. So you use the basic knowledge that you have in riding a bicycle to learn on riding motorcycle. So that concept is called transfer learning. Okay, so the pre-trained language model that has been trained on a very big data, they have certain knowledge, isn't it? So we can use the knowledge using our own data to fine-tune the model, fine-tune it, make it more efficient to use to do your purpose. Let's say for sentiment analysis, then that one is another way. I think nowadays they use that because they have a lot of pre-trained language model. Okay, but not as English. English there are many, but like Bahasa Malaysia, there are one. I think Indonesian also they have. Okay, some people have worked on like Bahasa Malaysia. They have a model like it's called Malaya model. In Malaya model, so they have developed a mini bird. Okay, for that languages. So if they have that, we can use. Okay, we can use that to develop our own application. Okay, Rafael.
Fine. Thank you. Thank you for the answer.
Next, the question from all participants, or you can type your question in chat panel. Okay, okay.
Excuse me, Mr. Dr. Halizah.
Yes.
Can I ask a question before we wait for another question from our mahasiswa to ask their question? Let me ask you some question about your presentation. First of all, I'd like to thank your presentation for giving us. Thank you very much for giving us such an engaging and comprehensive presentation. It was truly enlightening on the NLP topics. Hopefully, our fellow students will be able to grasp the concept. And for those who are still confused or have any questions, please directly ask Dr. Halizah while she's still with us in this event. Her expertise and presence hopefully can provide us valuable clarification on the things that you are still confused. While waiting for the question to arise, if any question arise, I might as well ask some question. Only one actually. It's about data. In several NLP applications, NLP heavily relies on the language that is used. For English, we know that we have abundant data set available in English. Since English is a globally used language in every nation, English is used for everyone, and everyone always learn English after their mother language. However, for language such as Malaysia, Indonesia, or other language other than English, the data sources are often limited or not as abundant. In NLP case, is there any techniques available similar to augmentation technique in image processing or data series processing, which have augmentation technique to make some synthetic data or some smote, such as smote, in that is effectively used only for NLP application? That's my question. Is there any technique that can be used to address the low resource in the data set other than English language?
Okay, so low resource. Okay, one way, of course, we need to collect our own data and create it. Okay, create. That's one way lah. Okay, another way is the one that like Malaya model do. What they did, they translate it into Malay. They translate the English to Malay. Okay, because of now the English translation is correct, more correct. Okay, so more accurate. Then they can use translation. Okay, but other way that you can do, if we have the paraphraser lah in Malay or Indonesia lah. Okay, okay. But now what we need to do, of course, from my literature review, they said not many resources on Indonesian and Malaysia. One thing that we can do is, if you have something, you make it public. Okay, you share with others. Okay, I have some PhD student. They share. I ask them to just share. Maybe, because sometimes we don't know. Someone maybe want our data, isn't it? And then, of course, that problem. Okay, of course, we need to create. Okay, to create our own corpus. Or if let's say we don't have, we can do like translation and so on. Okay.
Okay, so to summary your opinion about the technique to tackle this low resource data set, first we have to translate our available data set to increase the number of the data set. And then we must increase the availability of our data sets. We must publicize our data set, which we have made ourselves, so it can be used and increase the number of insights the data sets available to public in our language, such as Indonesia or Malaysia, in specific tasks such as machine translation, sentiment analysis, or other NLP applications like that. Dr. Halizah.
Yeah, in fact, there is one website, they call it Language Resources. Okay, ALREG, whereby they run a conference every 2 years. Okay, so from the website, I see that many of researchers share their data. Okay, many languages. Okay, if you want to, let's say, charge it, yeah, of course, you can put charge, or you can put it like public or freeware. Okay, so that's one resources that we can actually, you can refer to find out our data. Or maybe, let's say we have a university, isn't it, in Indonesia, in Malaysia. Maybe we can work together and then we come up with one portal to share our data. That also can be done. Yep.
Okay, so we could make our own repository data for research purpose analysis like that. Yes. Yeah, I think that answers my question, and looks like there's no any question arise. So I think I'll get the session. I'll give it back to Miss Yunila. Miss Yunila, the time is yours. Thank you very much for your answer, Dr. Halizah.
You're welcome. Okay.
Thank you very much, Mr. Sandy, for the question. Well, is there another question from participants? While waiting, I want to. I'm curious. Like I told before in the first session to all participants that Dr. Halizah has a recognition about the product. Yeah. Maybe would you like to share us about your recognition product, Dr. Halizah, MU Intellect? You can tell us a brief story about your product, maybe.
Okay.
So yeah, it can add our knowledge, and we know about your product more.
Okay. The product is a collaboration, me and English lecturer. Okay, English lecturer from Language Center. So we work both together with one body called Majlis Peperiksaan Malaysia. Majlis Perperiksaan Malaysia is the one that body that handle exam, English examination. That one is MUET. We call it MUET. So we developed two products. Okay, one is MUET Lex. MUET Lex meaning that it consists of words that always occur in MUET papers. Okay, MUET exam papers. And then we provide the meaning, how to the example of sentences, and how to pronounce. Okay, so meaning that the student that will take MUET will use the app and learn about the words that always occurs. Okay, and another one is MUET Corpus. MUET Corpus is a collection of MUET papers, but it focuses on the concordance. Concordance meaning that you have the word, and what is the word that always occur behind, before, and after it. Okay, that's called concordance. To meaning that the student will learn, okay, using this word, okay, what is normal the word that before it and after it. So that's about actually the product. Okay, that's two product that we actually develop.
It's very interesting product because I'm very curious. So two products got many medals or
Yeah.
Okay, Dr. Halizah, I
Okay.
think it is at the end of the session. And thank you very much for your presentation, for joining with us. And then I think this is new knowledge for us, especially for students have never taken before this project, this material natural language processing. It's very valuable for us. Okay. Before we end the session, would you like to give us a brief close statement to our students, maybe?
Okay. First of all, I would like to say thank you very much. Okay, that inviting me. I love sharing this knowledge, that what I have, and I think that I hope that all of the students get benefits. And if you have something that we want to ask me or share with me or work together with me, okay, I just now my email. Okay, you can contact me through my email. Thank you very much. Okay, to all of you.
Okay, thank you very much, Dr. Halizah. Once again, thank you for your great and valuable knowledge sharing today. And our participants may give big applause to our amazing guest today, Dr. Halizah. Thanks to all the participants for your attention and participation in this specific lecture event. We hope that all we have learned and discussed today will give benefit for us. On behalf of the moderator of the session, I apologize if there is any mistake in guiding this session. Once again, thank you very much, Dr. Halizah, and all the participants, and see you again in the next opportunity. Assalamualaikum warahmatullahi wabarakatuh. I will return to MC.
Waalaikumsalam.
With that, we have come to the end of our program. On behalf of Informatika GIP, I extend my heartfelt gratitude to our distinguished speaker, Dr. Halizah Basiron, PhD, MSc, PhD, and to all of you who have joined us today. Your presence and enthusiasm have made this event a resounding success. We hope that you have found this visiting lecture insightful and engaging. May the knowledge shared here today continue to inspire and guide us in our pursuit of academic excellence. As the MC of this event, I would like to humbly apologize for any mistakes or shortcomings that may occur during my guidance of this program. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you very much, Dr. Halizah.
Thank you.
Selamat Sandi, selamat Pak Sandi.